Rest your hand somewhere soft and let it grow heavy. That hand is made of atoms. So is the pillow beneath your head, and the slow air moving in and out of you, and the faint warmth of the room around you. Everything you have ever touched, everything you have ever loved, everything you have ever been is built from these unthinkably small things. And here's the first quiet surprise, the one we'll wander toward tonight. For all their smallness, atoms are mostly empty, mostly stillness, mostly space. Tonight we're going to step inside one, not to study it and not to remember it, only to wander through it slowly, the way you might walk through an old cathedral late in the evening, with the lights low and your footsteps soft, looking up, breathing easy, in no hurry at all to leave. Let me tell you a little of what waits in there, my friend, so you can settle into it without bracing for anything. There is emptiness so vast it should unsettle us, and somehow only soothes. There is a tiny, hidden heart so dense that a single spoonful of it would outweigh a mountain. There are particles that drift through walls they have no right to cross. There is a kind of music written into the very shape of things. And there's one gentle question that the wisest people who ever lived have turned over for 100 years and still cannot answer. Here's the part that should let your shoulders fall. You don't have to hold any of this. Each piece of tonight stands entirely on its own, like a separate stone resting in a quiet garden. If you drift away somewhere in the middle and float back up a while later, you will have missed nothing at all. You can simply rejoin wherever you happen to find yourself. There is no thread you need to keep hold of, no place you're supposed to have reached by now. So let your jaw loosen, let your hands go slack, let the bed take your whole weight, all of it, so your body no longer has to do the quiet work of holding itself up. Let your breath slow on its own, without you arranging it. We're going somewhere very small and very strange and very beautiful, and there is all the time in the world to get there. If you could shrink yourself down small enough to stand inside a single atom, the first thing you would feel is how alone you are. Imagine the inside of a great cathedral, the kind with a ceiling so high it disappears into shadow, and a stone floor so wide that your footsteps echo and come back to you. Now place, right at the very center of that cathedral, a single grain of rice. That tiny grain is the nucleus, the dense little core of the atom. And the far walls of the cathedral, away on every side, that is roughly where the electrons drift. Between the grain of rice and those distant walls, there is almost nothing at all. No floor beneath you, no air to breathe, just space and quiet and the faint sense of something small glittering at the heart of it all. That is what you are made of. Not a tight little ball of stuff, but a vast, echoing hollowness with a speck at its center and a soft haze far out at its edges. The numbers are hard to hold in the mind, so let the picture carry them. The nucleus is something like 100,000 times smaller than the atom that surrounds it. If the core were a marble set down on the center spot of a football field, the nearest electrons would be drifting somewhere up in the very highest seats of the stadium, and everything in between would be empty. If you could gather every atom in your body and somehow squeeze out all that empty space, pressing only the solid parts together, the whole of you would collapse to something smaller than a single grain of dust. The you that fills these clothes, that leaves a warm impression in this bed, is by volume almost entirely nothing. And this is not some special softness belonging only to living things. The mountain is mostly empty. The deep ocean is mostly empty. The hardest steel ever forged, the densest stone, the iron anvil that rings like a bell when it is struck, all of them are, on the inside, the same vast and echoing hollowness, a faint scattering of tiny cores adrift in an immense quiet. When you knock on a heavy table and it answers with a solid, satisfying sound, you are hearing the deep song of something that is almost entirely empty space. Everything around you, everything you have ever leaned on or called solid, is built in just this way. Mostly nothing, mostly room, mostly stillness with a sprinkling of light at its center. And yet your hand rests on the blanket, and the blanket holds it. Your head lies on the pillow, and the pillow does not let it sink through. The world feels solid. It feels full. So here's the strange thing worth resting in for a moment. If matter is mostly empty space, why can't empty space simply pass through empty space? Why doesn't your hand slide down into the bed the way it slides into a patch of fog? The reason isn't that the atoms are pressed together the way two pebbles press when you close your fist around them. The reason is that they will not allow it. Out at the edge of every atom drift its electrons, each carrying a faint electric charge. And that charge pushes back against the charge of other electrons. When your hand comes down onto the blanket, the outermost electrons of your skin draw close to the outermost electrons of the cloth, and they press against one another, a soft, invisible cushioning holding the two surfaces the thinnest sliver apart. In all your life, you have never once truly touched the bed you sleep in. There has always been that tiny gap held open by a gentle electric refusal. And beneath even that, there's a deeper rule, one of the quietest and strangest in all of nature. No two electrons are permitted to crowd into exactly the same place and state at the same time. Matter simply will not let itself be doubled up. The world keeps a kind of order at its smallest scale, an insistence that everything have a little room of its own. And it is this insistence, far more than any hardness, that makes the floor a floor and the wall a wall. So when you sink back and let the mattress take your weight, picture what is truly happening. You are not lying on a slab of solid stuff. You are lying on a force. You are being held up ever so gently by the steady refusal of countless tiny things to overlap with countless other tiny things. The firmness beneath you is mostly emptiness holding emptiness, with the lightest electric touch in between. There is something quietly reassuring in that, if you let it sink in. The solidity of the world, the very thing that keeps you safe and stops you from falling, turns out not to be heaviness or fullness at all. It is space, kept politely apart. It is mostly nothing, arranged with enormous care. And inside that nothing, at the center of every single atom in you, and in the room and in the soft dark beyond the window, a tiny point quietly glimmers, small as a grain of rice in a cathedral, surrounded on every side by a vast and patient stillness. Picture a hummingbird beating its wings so quickly that they vanish into a soft blur. And now let the bird itself dissolve into that blur until only the haze is left hanging in the air. That haze is close to the truth of where an electron lives. For a long time, people drew the atom as a little solar system, a nucleus in the middle, like a sun, and the electrons swinging around it in tidy circles like planets on their orbits. It is a lovely picture, and it is printed in countless old books, and it is also, we now know, simply not how things are. An electron does not travel a neat path. It does not have a particular spot where it sits, waiting to be found. Instead, it exists as something far gentler and far stranger. A cloud of pure possibility, a soft smear of places where it might be, thicker in some regions and thinner in others, fading away toward the edges like breath on a cold window. We call it the electron cloud, and the name is honest. The cloud is not a swarm of many electrons. It is the single electron itself, spread out, not yet pinned to any one place. Picture a drop of ink released into a still glass of water. At first it is a sharp, dark point, but it blooms and softens and reaches outward until it has filled the whole glass with a faint, even shading, darker near the center, paler at the rim. The electron is something like that bloom of ink, except that the cloud is not made of tiny pieces drifting apart. It is the whereabouts of one thing, all of its maybes, holding open at once. And here's what tilts the mind. The electron does not seem to choose a single location until something reaches in and interacts with it. Until that moment, asking exactly where it is may be a question with no answer, not because we are not clever enough to find out, but because there may be no single spot for the finding. The electron is held in a state of and every possible place at once, faint and overlapping, like a chord rather than a note. When something does reach in and meet it, the cloud seems to gather itself in an instant, and the electron turns up somewhere definite, here and not there. Where exactly it appears, we can never say in advance. We can only say how likely each place is. The thick part of the cloud is where it will most often be found, the thin part where it will rarely turn up. The cloud is, in the end, a map of chances, painted softly across the empty space inside the atom. And the cloud behaves, in every test we have ever devised, like a true wave, not merely a smudge born of our ignorance. Send a single electron toward a pair of narrow openings, and it does not slip neatly through one or the other the way a thrown pebble would. It passes through both at once, as a ripple on water would, spreading out beyond them, overlapping with itself, leaving behind the soft banded pattern that only waves can make. One lonely electron, interfering with its own spread out presence, arriving as though it had quietly taken every path at the same time. It is a strange and gentle thing to picture. The smallest piece of matter moving not as a dot tracing a single line, but as a soft ripple feeling out the whole of its surroundings, trying everything before it ever settles anywhere at all. We have watched this happen, patiently, one electron at a time, and the banded pattern still builds itself up, speck by speck, as if each solitary particle somehow knew about all the places it might have gone. What this truly means, beneath the mathematics, is one of the questions that still divides thoughtful people, and no one can claim to have settled it. But the strangeness of the cloud itself is not in doubt. It has been tested in 1,000 careful ways, and the world keeps answering, yes, this is how small things are. They are blurred, they are spread out, they are possibility before they are fact. There is something tender in that, when you sit with it in the quiet. We tend to think a thing must be somewhere, fixed and findable, a marble that simply hasn't been located yet. But the electron is not a hidden marble. It is closer to a held breath, a softness that is not yet decided, a presence without a single address. The smallest pieces of you are not little hard specks. They are gentle clouds, leaning toward many places at once, faint as mist over a field at first light. And every atom in your resting body is humming with these soft clouds, billions upon billions of them, each one a smear of quiet maybes, glowing dimly in the dark, in no hurry to choose. By the oldest rules of physics, the atoms that make you should have collapsed in an instant. And yet here you are, breathing slowly in the dark, entirely intact. Think for a moment about how the older picture of the atom was meant to work. A tiny core at the center, carrying a positive charge, and an electron carrying a negative charge, sweeping around it in a curve. Opposite charges pull toward each other, the way the right ends of two magnets leap together. So the electron is forever falling inward, pulled toward the core, and only its constant circling keeps it from dropping straight in, the way a stone whirled on a string stays out only because you keep it moving. But there was a problem, and it was a serious one. According to the laws that govern electricity and light, any charged thing that curves and circles and accelerates must pour out energy as it goes, shedding it as faint radiation, like a wet wheel flinging off droplets as it spins. And as the electron bled away its energy, it would have nothing left to hold its wide path. It would spiral inward, faster and tighter, winding down like water circling a drain, until it crashed into the core and the atom simply ceased to be. When the early scientists worked out how long this would take, the answer was almost unimaginably short. Not a year, not a second, but something near 10 trillionths of a single second. Every atom in the universe should have wound down and fallen silent in far less time than the blink of an eye, back near the very beginning of everything. The bed beneath you, the air in your chest, the warm weight of your own body, none of it should be here at all. And yet it is here. The atoms have not fallen in. They have held themselves open and stable for nearly 14 billion years, steady as anything could be. So what catches the electron? What invisible floor does it come to rest upon, just above the core, and refuse to sink below? The answer is one of the great gentle surprises of the small world. There is a lowest place the electron is allowed to be, and once it settles there, it can give away no more. It has reached the bottom rung of a ladder that has no rung beneath it. In our everyday world, a thing can always fall a little further, slow a little more, lose one more drop of energy. But inside the atom, energy comes only in set amounts, like coins of a fixed size, and the electron in its lowest state has run out of coins to spend. It cannot shed a little more because there is no smaller amount to shed. So it simply stays, hovering, holding its place, unable to fall. This is one of the strangest gifts the small world keeps, that so many things which look smooth and continuous to us are, underneath, built out of steps. We picture energy as something that can be poured out in any amount we like, a stream that can always be coaxed to trickle a little slower. But for the electron bound to its core, energy comes only in particular sizes, like the rungs of a ladder with nothing in the gaps between them. It can rest on one rung or another, but never hang at some halfway height, because that halfway height does not exist for it at all. And the lowest rung is the one that matters most here, as because below it there is simply no more ladder. The electron resting there has nowhere left to step down to. It is not being propped up by anything pushing back against it. It has reached the very floor of what is possible, and the floor of the possible does not give way beneath anyone. There's a deeper reason woven through this too, and it is quietly beautiful. The more tightly you try to pin the electron near the core, squeezing it into a smaller and smaller space, the more restless and fast it is forced to become. the way a frightened bird trapped in a smaller cage only beats its wings harder. Push it inward and it pushes back with motion. So the electron settles at a kind of truce, a balance between the inward pull of the core and its own resistance to being confined too closely. It comes to rest not at the very center, but a small distance out, in the lowest, calmest state it is allowed. Sit with what that means, here in the dark. Every atom in you is holding itself open against a fall that, by the simplest reasoning, should have happened long before the earth was made. Your stability, the plain fact that you stay yourself from one moment to the next, that your hand is still a hand and your breath still rises and falls, rests on this quiet refusal at the smallest scale. The electron has reached the bottom, and the bottom holds. Picture a single low note struck once on a deep string that somehow never fades, never dies away, but simply rings on, soft and unwavering, holding the whole house steady around it. That is the electron in its resting place, settled forever just above the heart of the atom, neither falling nor leaving, only quietly, endlessly staying. There is a spinning thing inside every atom that is not, in any ordinary sense, spinning at all. Every electron carries a property that the early scientists called spin, and the name stuck, even though it has turned out to be one of the most quietly misleading words in all of physics. When they first noticed it, they imagined the electron as a tiny ball turning on its axis, the way the earth turns, the way a coin spins on a table. A spinning ball of charge would behave like a minuscule magnet, with a north end and a south end, and that is exactly what the electron does. So the picture seemed to fit, and the words seemed right. But then came a difficulty that has never quite gone away. As far as anyone has ever been able to measure, the electron has no size at all. It is not a tiny ball. It is a point, a place with no width and no surface and no interior, smaller than small. And a point cannot spin. There is nothing there to turn. You cannot set a mathematical dot rotating. The very idea comes apart in your hands. And yet the electron unmistakably has this property. It really does behave like something turning, really does act like a tiny magnet, really does carry this strange inner whirl that the equations insist is there. So we are left with something genuinely odd and worth pausing over. The electron has a spin, and nothing is spinning. It has the effect of a turning thing without the turning. It is as if you walked into a quiet room and felt the breeze and the swirl of a great wheel going round and round, and looked and found no wheel, only the motion itself, hanging in the air with nothing to carry it. This is not a gap in our knowledge waiting to be filled with a better picture. The strangeness is built into the thing itself. Spin is simply a property the electron has, as basic to it as its charge, a fundamental fact of what it is to be an electron, and there is no smaller, more familiar machine hidden underneath to explain it. We can measure it with exquisite precision. We can predict exactly how it will behave. We just cannot point to the thing that turns, because there isn't one. There is something stranger still about this whirl, something that pulls even harder against common sense. Take any ordinary spinning thing, a coin, a top, a wheel, and turn it all the way around, back to where it began, and it looks exactly as it did before. One full circle, and everything is restored. But the electron's spin does not obey this simple rule. Turn it once, fully around, a complete circle, and in a deep and measurable sense, it has not yet come back to itself. It must be turned around twice, through 2 full circles before it truly returns to the state it started in. This is not a figure of speech or a clever way of talking. It is a real feature of what the electron is, woven into its nature, and it has no comfortable picture anywhere in the world we can see and touch. The spin lives by rules that coins and tops and wheels, all the spinning things we know, simply do not follow. And here is where this pictureless whirl reaches out and touches the world you can see and hold. Because each electron behaves like a tiny magnet when great numbers of them line up and point the same way inside a piece of iron, all their little magnetic poles add together into one pole large enough to feel. That is what a magnet is. The cheerful magnet holding a child's drawing to the refrigerator door, the compass needle that swings to find the north, the quiet click of a fridge sealing shut, all of it traces back, in the end, to this whirl with nothing whirling, multiplied across countless electrons, they all leaning the same way. It reaches into the body too. Deep in the heart of certain atoms, the cores themselves carry their own version of this spin. And when a person lies still at the great humming ring of a hospital scanner, it is these tiny inner whirls that are gently nudged and listened to, their faint songs gathered up and woven into an image of the soft tissues within. A machine built to see inside you works by speaking to a property that has no shape and no moving part, only the ghost of a turn. Let that settle over you in the quiet. So much of what we call solid and ordinary, the snap of a magnet, the steadiness of a compass, rests on something we cannot even properly imagine, a spin without a spinner, a turning with nothing that turns. The world is stranger underneath than it ever lets on at the surface, and you are made of that strangeness, through and through. Picture a compass needle in a dim and silent room, trembling once, then swinging slowly, gently around until it comes to rest, pointing quietly north, held there by a force you cannot see, set in motion by a turning that was never really there. The electrons in an atom can only hum in certain shapes, the way a plucked string can only sing certain notes. Pluck a guitar string in a quiet room, and you do not get just any sound. The string can vibrate as a single gentle arc, swelling in the middle, and that gives you its lowest, fullest note. Or it can divide itself in two, with a still point in the center, and ring a higher note. Or in 3 or 4, each with its own clear tone. But it cannot do just anything in between. The length of the string, fixed at both ends, allows only a particular family of patterns to fit, only the ones whose waves come out even at the ends. Every other wobble fights itself and dies away. What is left is a ladder of pure, allowed notes, written into the string by its very shape. Something remarkably like that is happening inside every atom you are made of. The electron, as it turns out, is not only a tiny speck. It is also, in some deep way, a kind of wave, a soft ripple of presence wrapped around the core of the atom. And just like the string, that wave can only settle into certain patterns, the ones that fit smoothly around the atom without clashing against themselves. Each allowed pattern is a particular shape the electron can take, a standing wave hanging in the empty space around the core, and only these shapes are permitted. Everything else simply cannot hold. When we map out what those shapes look like, they are unexpectedly graceful. The simplest is a soft, even sphere, a gentle glow surrounding the core in every direction at once, thickest near the middle and fading outward like a cloud lit from within. The next family looks like a pair of rounded lobes reaching out in opposite directions, something close to a dumbbell, or two soft balloons tied at a single point. Climb higher and the shapes grow more elaborate still. A clover leaf of 4 petals, rings and rosettes, and gently folded forms, each one a particular way the electron's wave has chosen to fit around the heart of the atom. These are not pictures we invented for the sake of teaching. They are the real architecture of matter, the actual shapes in which electrons arrange themselves, and they are why the world is built the way it is. The way atoms join hands to form water or stone, or the long, delicate chains that make up a living thing, depends entirely on the shapes of these clouds and how they reach toward one another. The patterns the electron is allowed to take become, at the largest scale, the patterns of everything. And just as a single string can sound more than one note at once, blending its pure tones into the warm, full sound your ear actually hears, an electron can blend its allowed shapes together. It can mix a soft sphere with a reaching lobe, fold 2 patterns into one, and so make new forms tilted and pointed in particular directions. This is why the bonds between atoms reach out at the precise angles they do, why a molecule of water carries its gentle fixed bend, why the building blocks of living things branch and twist and fold into exactly the shapes that let life function at all. The angle of every bond inside you, the quiet geometry of breath and blood and bone, traces back to these blended notes of the electron, these chords of shape ringing softly within each atom. The world is not built only from a handful of pure tones. It is built far more beautifully from their harmonies. There is an old and lovely way to see this idea with your own eyes. Take a flat metal plate, scatter fine sand across it, and draw a bow across its edge so it begins to ring. As the plate vibrates, the sand dances and then gathers, settling along the quiet lines where the plate is barely moving, abandoning the parts that shake. And what appears out of the chaos are intricate and perfectly ordered patterns, stars and flowers and webs of curving lines, different for each note the plate sings. The shapes were always possible, hidden in the plate. The vibration simply calls them forth. The atom is doing something of the same kind, ringing softly in 3 dimensions, its electron settling into one of the patterns its own nature allows. The shapes of all matter are, in a real sense, the visible music of these tiny instruments, frozen mid-note, held still. Let that thought rest gently on you in the dark. You are not built from featureless grains of stuff piled together. You are built from shapes that fit, from a small set of graceful patterns repeated past counting, the spheres and lobes and clover forms of countless humming atoms. There's a hidden geometry threaded all the way through you, a quiet order, the same kind of order that lets a string ring true. Picture the last note of a softly plucked string, fading slowly into silence, and the fine grains of sand on a stilling plate drifting at last into a pattern of curving lines, settling, and coming to rest. Imagine a vast and quiet theater in which no 2 people are ever allowed to share a single seat. This sounds like the simplest courtesy, the kind of rule no one would think to question. And yet a rule almost exactly like it, written into the smallest scale of the world, is the reason there is anything interesting to be made of at all. It is the reason there is iron and oxygen and gold and carbon, the reason there is water and stone and bone and breath, the reason you are a particular, structured, living thing and not a featureless smear. One quiet prohibition holds up the entire variety of the world. The rule is about electrons, and it is simple to say. No two electrons in the same atom may share precisely the same state, the same arrangement of place and energy, and that strange inner spin. Each must have its own. They cannot pile into the lowest, most comfortable place altogether. The first one settles in, takes the best seat closest to the core, and from then on that exact seat is taken. The next electron, finding it occupied, must take a slightly different one, and the next, a different one again, and so on, each forced a little further out, a little higher, filling the available places one by one, like guests arriving at the theater and finding the front rows already full, settling reluctantly into the seats behind. Take that one quiet rule away, and imagine what would happen. Every electron in every atom would tumble down into the single lowest, snuggest place, all of them crowded into the same tiny state at the heart of things. And if they did, every atom would become very nearly the same as every other. The rich and varied family of elements, the whole patient ladder from the lightest gas to the heaviest metal, would flatten into a dull sameness. There would be no chemistry, because chemistry is the conversation between the outermost electrons of different atoms, and there would be no outermost electrons to speak of. Only a uniform huddle at the bottom. There would be no structure, no variety, and so no us. But the rule holds, and so the electrons stack outward in their orderly shells, and it is precisely the arrangement of those outer electrons, how many there are and where they sit, that gives each kind of atom its character. It is why one element is a soft gray metal and another a colorless gas, why one clings eagerly to its neighbors and another drifts aloof and alone. The great chart of the elements that hangs in every classroom with its neat rows and columns is in truth a seating chart, a map of how the electrons fill their places, one careful seat at a time. And this rule reaches deeper than chemistry, all the way down to a quiet strangeness about the electrons themselves. For they are not merely similar particles politely keeping their distance from one another. Every electron in the universe is exactly, perfectly identical to every other, with not the smallest difference between them. No scratch, no marking, no private history, nothing at all to tell one from the next. They are interchangeable in the most complete and absolute way that anything can ever be. And it is in part because they are so flawlessly alike that nature treats them with this strict insistence on separateness, this firm refusal to let any two of them share a single state. The rule is something like the answer the world gives to the deep puzzle of things that are truly, perfectly indistinguishable. Out of that profound sameness, woven together with this profound apartness, comes all the difference and richness and variety you see spread around you. This same insistence on a little room reaches all the way out to the depths of stars. When a star like our sun finally burns through its fuel and its core can no longer hold itself up by heat alone, gravity begins to crush it inward, harder and harder, trying to squeeze it down to nothing. And what finally stops the fall, what props up the spent ember of a dead star against the full weight of its own gravity, is nothing more than this refusal of electrons to share a state. They simply will not be crowded past a certain point. The same rule that keeps the theater seats one to a person holds up the cooling cinder of a star steady for billions of years. There is something to rest in here, quietly, as you lie still. So much of the structure of the world, all its richness and difference and detail, springs from a single act of gentle order, an insistence that everything be allowed its own small space. Crowding is forbidden, and from that forbidding comes everything. The variety of the whole universe rests in part on a kind of cosmic good manners. Picture the theater now, late and hushed, every seat filled and only one to a seat, the audience settled and still, the lights low and golden, no one crowding, no one pushed, each in their own quiet place, waiting in the warm dark for the music to begin. There's a softness at the very center of things that can never be sharpened away, no matter how closely we look. We are used to the idea that anything blurry can, in principle, be brought into focus. A smudged photograph, a distant shape on the horizon, a word half heard across a room, all of these grow clearer with a better lens, a closer look, a sharper instrument. So it is natural to assume that the haziness of the small world is the same kind of thing, just a sign that our tools are still too clumsy, that one day we will build something fine enough to see it all crisply. But the small world is not like that. Its softness is not a smudge on the lens. It is woven into the thing itself, and it will not come into focus ever, because there is nothing sharper underneath. The clearest way to feel this is to try to do two simple things to a tiny particle at the same time and watch them quietly refuse. Suppose you want to know exactly where the particle is, to pin its position down to a precise point. And suppose you also want to know exactly how it is moving, how fast and in what direction it is traveling. In our large world, these two questions sit comfortably side by side. You can know precisely where a thrown ball is and precisely how it is moving, both at once, no trouble at all. But in the world inside the atom, these two pieces of knowledge are bound together by a strange and unbreakable bargain. The more sharply you fix one, the more the other softens and spreads. The way pressing down hard on one end of a long balloon only makes the other end bulge out. Pin the particle's place down very precisely, narrowing it to the smallest possible point, and its motion becomes wild and uncertain, smeared across a wide range of possible speeds, impossible to specify. Pin its motion down very precisely instead, and its location blurs out in return, spreading into a haze of possible places. You may have one sharp and the other soft, or both a little fuzzy together, but you can never ever have both perfectly crisp at once. The world simply does not hold that much sharpness in one spot. And the deep, quiet point is this. This is not because our measuring is too rough, knocking the particle about and spoiling the reading. It is something stranger and more fundamental. The particle itself does not possess a perfectly sharp place and a perfectly sharp motion at the same time, waiting for us to be clever enough to read them off. The sharpness is simply not there to be found. The fuzziness belongs to the world, not to our eyes. Reality, at its smallest scale, keeps a little of itself soft, always by its own nature. This same softness carries a quiet consequence that is almost tender. It means that nothing in the small world can ever be perfectly, completely still. To be perfectly still would be to have an exactly fixed place and an exactly fixed motion of zero, both of them sharp at once. And that is the very thing the world will not allow. So even at the coldest cold imaginable, colder than the empty dark between the stars, the smallest pieces of things never quite come to rest. They keep the faintest tremble, a last whisper of motion that can never be hushed away, because to hush it entirely would make them too sharply defined to exist at all. There is, woven right into the fabric of matter, a gentle and permanent restlessness, a soft shimmer at the bottom of everything that is, a stirring so quiet and so deep that it can never be stilled and never needs to be. This is not a small or fragile idea. It has been tested with extraordinary care for the better part of a century, and the world keeps answering the same way. There is a limit, a built-in graininess, beneath which no thing can be both perfectly placed and perfectly known. It is one of the most reliable facts we have, and what it tells us is that perfect total knowledge of even a single tiny particle is not merely hard. It is, in a real and permanent way, off the table. Let that rest gently on you in the dark, because there is a strange peace in it. We so often feel that everything could be known, if only we looked hard enough, pressed close enough, refused to blink. But the world itself holds back. It keeps a soft veil over its smallest parts, not out of secrecy, but out of the simple way it is made. There will always be a little mist at the bottom of things, a place where looking harder only makes the rest go softer, where the right response is not to strain, but to let it be. Picture a still lake at dawn, its surface lost under a low, gentle fog, the far shore dissolved into pale gray, everything soft-edged and quiet. You could lean closer, you could reach out a hand, but the fog would only drift and regather, never quite lifting. So you stop reaching, you let the mist stay, you let the morning be soft. Roll a ball gently toward a hill too steep for it to climb, and in our world it always rolls back down. In the world inside the atom, every so often, the ball is simply on the other side. This is one of the strangest and most quietly astonishing things small particles can do, and it has a fittingly strange name: tunneling. Though nothing actually digs a tunnel, a particle faced with a barrier it has no business crossing, a wall of energy too high for it to surmount, will now and then turn up on the far side of that wall without ever having gone over the top, as if it had passed straight through the solid hill and stepped out blinking into the daylight beyond. To feel why this is so shocking, picture yourself pushing a ball up a slope. If you give it a good shove, but not quite enough to reach the crest, you know exactly what happens. It climbs partway, slows, stops, and rolls back down to you. It cannot reach the other side because it ran out of the energy needed to clear the top. This is the plainest common sense, and in the large world it is simply always true. A ball without enough push does not get over the hill, ever. But the small particle is also, in its quiet way, a spread-out cloud of possibility, a soft wave of maybes rather than a hard little marble. And when that wave meets the barrier, it does not stop dead at the foot of it. It seeps into the wall, growing fainter as it goes, dimming like light passing into deep water. If the wall is thin enough, a faint trace of the wave reaches all the way through to the other side and emerges, weak but real. And because the wave describes where the particle might be found, that faint trace on the far side means there is a small but true chance of finding the particle there. Beyond the barrier, it could never have climbed. Most of the time it stays on the near side, as common sense expects. But sometimes, quietly, it appears on the other side instead, having passed through the impossible. And here is what should make you smile in the dark. This is not some rare curiosity tucked away in a laboratory. The warmth of the sun on a summer afternoon, the light you have lived your entire life beneath, exists because of this very thing. Deep in the core of the sun, the particles that need to slam together to release its energy are all positively charged, and like charges push each other away fiercely the closer they get. By the ordinary reckoning, the heart of the sun is not even hot enough to force them together against that push. They should never quite meet. The sun, by that reasoning, should be dark. But every moment, countless particles tunnel through that wall of repulsion, slipping past the barrier they could not climb, meeting and merging and pouring out light. The sun shines because the impossible happens, quietly, ceaselessly, deep in its core. It reaches into smaller corners too. Certain heavy atoms slowly break apart over time, casting off tiny pieces from their cores, and this happens because those pieces tunnel their way out of a grip that, by all the ordinary rules, should hold them forever. The steady, faithful clock of such decay, which lets us read the age of ancient stones and old bones, is in truth the patient ticking of particles escaping through walls. And the very tools we use to feel the shape of single atoms, to map their gentle hills and valleys, work by coaxing electrons to tunnel across a tiny gap, a whisper of current flowing where, by common sense, none should flow at all. It even quietly shapes the long, slow story of the universe itself. Given enough time, things that seem perfectly stable, locked and settled in place, can find their way to a lower and calmer state by slipping through a barrier they could never have crossed head-on, as though the world were forever gently leaking toward its quieter possibilities, one impossible passage at a time. And because this slipping through is always a matter of pure chance, no one can ever say which particle will cross or when. We can know with great precision how a vast crowd of them will behave across the long ages, and never the fate of any single one among them. The wall stands there, solid and forbidding, and yet now and then, softly, without warning or reason, something is simply on the far side of it, having gone where it could never have gone. Let that settle over you as you rest. The warmth that ripens the fruit, the light that fills the sky, the slow clocks hidden in the rocks, all of them lean on this soft impossibility, this gentle slipping through of walls. The world you know, the bright and solid daytime world, is held up in part by particles doing the one thing they ought not to be able to do, over and over without fuss since the beginning of time. Picture the warmth of sunlight remembered on your skin, the kind that soaks into you on a still afternoon, easing every muscle. That warmth began as countless tiny things slipping silently through a wall they could never have climbed, and it traveled all that long way, just to come to rest, gently, on you. At the heart of every atom sits a small impossibility, a huddle of particles that should be flying violently apart, held instead in the tightest grip in all of nature. To see why this is so strange, look closely at that heart, the core, the nucleus. Packed into it are the particles that carry positive charge, pressed together in a space almost unimaginably tiny. And positive charges, as anyone who has fought to push the wrong ends of two magnets together knows, do not like to be near one another. They shove each other away, and the harder you force them close, the more furiously they resist. In the cramped quarters of the nucleus, with these charges crushed together far tighter than two magnets ever are, the outward push is enormous, a coiled and straining pressure desperate to blow the whole core apart in an instant. And yet the core holds. It does not fly apart. It sits there, calm and stable, at the center of nearly every atom in your body and in the world around you, steady for billions of years. Something must be holding it together, something stronger than that fierce electric shoving, or there would be no atoms at all, and no us to wonder about them. That something is a force, and it is the strongest force we know of in the whole of nature. We call it, plainly, the strong force, and within the close quarters of the nucleus, it utterly overpowers the electric push, gripping the particles together in a hold that nothing else can match. Where the charges shove outward, the strong force hauls inward, harder, and wins, and the core stays whole. But here's the quiet, beautiful catch, the thing that makes the strong force so unlike anything in our daily lives. Its mighty grip reaches almost no distance at all. It is overwhelmingly powerful, but only across a span about as wide as the nucleus itself. A reach so short it is hard to put into words. Step even a little beyond that tiny range, and the strong force vanishes, fading to nothing with astonishing suddenness, like a grip that is crushing at the touch, but releases entirely the moment you draw back a hair's breadth. It is the strongest thing there is, and also the shortest reaching, a fierce embrace that only works when everything is pressed almost perfectly together. This is why the core can stay so small and so tightly bound. The strong force does its work only in that tiny inner world, holding the crowded particles in a knot so tight that, under ordinary conditions, nothing can pull them apart. And the way it does this, as best we understand it, is through a constant, restless exchange among the particles, a ceaseless passing back and forth of still smaller things between them, like a frantic game of catch played faster than thought, binding the players together by the sheer endless flurry of the throws. The grip is not a still thing. It is a blur of constant exchange, a stillness made of furious activity. And the strength of this grip is almost beyond reckoning. When a new core is built, when its particles first fall into that tight embrace, a small portion of their mass is given up, released into the world as energy, the energy of the binding itself. It seems a tiny thing, a mere whisper of mass turned loose. But the strong force binds so fiercely that even this whisper, gathered from countless cores, is the very same energy that lights the stars and warms the worlds that circle them. The sunshine of a whole long afternoon, the slow, patient heat that has nursed every living thing this planet has ever held, is in large part simply the strong force letting go of a little of its hold, deep in the heart of a star, as fresh cores are forged and bound together. The grip that holds the atom together is also, in the moment it tightens, the fire that lights the sky. And all of this fierce hidden struggle at the smallest scale, builds the steady world you know, the iron carried in your blood, the calcium that makes your bones firm, the gold in a ring, the carbon threaded through every living cell. All of it has a core held together by this short, overwhelming embrace. Every solid, lasting thing you have ever touched owes its very existence to a grip that reaches no further than the width of a few specks, and yet holds the entire architecture of matter together against a pressure that would otherwise tear it to pieces. Let that rest in your mind as you lie still. At the center of everything you are, in every atom, the quiet battle is forever being won. A force too strong to imagine and too short to reach beyond the tiniest distance is holding the core together, patiently, faithfully, billions upon billions of times over, throughout your whole body, throughout the whole world, throughout the long, long age of the universe, and it never lets go. Picture a hand closed gently but firmly around something small and precious, the fingers folded in, the grip sure and unwavering, keeping safe what it holds, asking nothing, simply holding in the warm dark and never tiring. Step onto a scale, and almost none of the number you see comes from anything you could honestly call solid. This is one of the deepest and most surprising truths about what you are made of, and it takes a little while to sink in, so let it come slowly. Most of your weight, very nearly all of it, is not matter at all in the way we usually picture matter. It is energy. Bound, restless, trapped energy, held still inside you, and we have simply learned to call it weight. To see how this can be, look once more into the core of the atom, into one of the particles that gives it most of its mass. We know by now what that particle is built from. Inside it sit a small number of even tinier pieces, the truly fundamental specks, the smallest bits we know of, bound together to make the larger whole. You might reasonably expect then that if you added up the weight of those tiny inner pieces, you would get the weight of the particle they form, that the whole would simply be the sum of its parts, the way a bag of marbles weighs as much as all the marbles inside it. But that is not what happens, and the gap is staggering. When you add up the masses of those tiny inner pieces, they account for only about 1 part in 100 of the whole. Barely a single percent. The other 99%, almost the entire weight of the particle, does not come from the pieces at all. It comes from something far stranger, from the furious motion of those pieces, racing about inside at tremendous speed, and from the immense energy of the force field that binds them together, the seething, straining grip that holds them in. This is possible because of one of the deepest facts we have ever uncovered about reality, that energy and mass are at bottom 2 faces of the same thing, and one can become the other. Energy has weight. Motion has weight. The straining of a powerful field has weight. And so the wild inner storm inside the particle, the racing of its tiny pieces, and the roaring of the field that holds them, all of it presses down on as surely as any solid stone, because all of it is, in the deepest sense, the same currency as mass. So when you open up the particle expecting to find it packed with heavy little stones, you find instead something closer to an almost empty box that nonetheless weighs a great deal. Its heft coming not from its few tiny contents, but from the roaring motion and the powerful field caged within it. The weight is in the storm, not in the stones. There's a beautiful turn hidden in all of this. We are used to thinking of energy as something light and fleeting, a flash, a warmth, a thing with no real substance to it, while mass is the heavy, solid, dependable stuff of the world. But here, the two quietly trade places. Take the tiny pieces caged inside and let them race ever faster. Pour more energy into their motion, wind the inner storm a little tighter, and the whole thing grows heavier, more sluggish to push, harder to set moving, and harder to stop. The faster the storm rages within, the more stubbornly the whole resists. Energy, caged and bound and refused any escape, becomes the very thing we feel as weight. The heaviness of solid matter is, in the deepest sense, motion that has been trapped and cannot get out, a fury held so tightly and so completely that it has gone perfectly still, and that captured stillness is exactly what presses down, warm and heavy, into the bed beneath you. And this is not some exotic exception tucked away in a corner of physics. It is the rule for nearly all the ordinary weight in the world, and that means it is the rule for you. The great majority of your body's mass, the weight you feel pressing into the bed right now, the heaviness gravity gives you, does not come from solid stuff in any simple sense. It comes from energy, bound and held inside the cores of your atoms, a captured tumult held perfectly still. You are, to a startling degree, made of trapped motion. You are, in a real sense, woven from bound light and ceaseless inner storm, gathered up and stilled into the quiet shape of a resting body. Let that thought rest gently over you in the dark, because there is wonder in it. The very heaviness that holds you down on the mattress, the solid, undeniable weight of your own self, is mostly not solid at all. It is energy at rest, a storm asleep, a great roaring activity bound so tightly and so deep that, from the outside, it feels like nothing more than the simple weight of a body lying still. Feel your own weight now, sinking softly into the bed, that warm and grounded heaviness. Almost all of it is a hidden storm, gathered and quieted inside you, held so perfectly still that it has become only this, the gentle, settled weight of you at rest in the dark. Pull hard enough on the smallest pieces of matter, and instead of coming apart, they make more of themselves. Deep inside the core of an atom, packed into the particles that give it weight, sit even tinier things, among the smallest pieces of matter we know of. They come bound together in little groups, never wandering loose, always held close by a force so strong it has earned the plainest of names. And here's the strange thing about that force, the thing that sets it apart from every pull and push you have ever felt. In the ordinary world, forces grow weaker the further apart things drift. Move two magnets apart and their tug fades. Step back from a fire and its warmth thins. But the force binding these tiny pieces does the opposite. The further you try to pull them apart, the harder it pulls them back. Picture two small beads joined by a band that never tires and never slackens. When the beads sit close together, the band hangs loose between them, and they drift almost freely, barely feeling each other at all. But begin to pull them apart, and the band draws taut, and the further you stretch it, the more fiercely it resists, storing up more and more strain with every inch. In our world, if you pulled hard enough, the band would finally snap, and you would be left holding one bead in each hand, separate at last. But that is not what happens here. When the strain in the band grows great enough, the energy you have poured into the stretching does something astonishing. It becomes new matter. Out of that stored energy, two fresh pieces simply appear, one springing into being at each broken end, so that instead of two lonely beads, you now hold two bound pairs. Pull them apart and you have made more of them. They will not be made to be alone, and there is a reason the bond behaves like a taut strand rather than spreading thin and fading, as most pulls do. The force between these tiny pieces is carried by a kind of messenger that flits ceaselessly between them. And unlike the messengers of other forces, this one is sticky even to itself. The messengers cling to one another as readily as they cling to the pieces they bind. So instead of fanning out into the surrounding space and growing weak with distance, the way the reach of a magnet thins as it spreads, the force gathers itself into a tight, narrow rope running straight between the pieces, holding together rather than dispersing. Stretch that rope, and because it refuses to thin, it simply stores up more and more strain along its length, until at last the strain itself bursts into new matter. The grip does not weaken across distance because it will not allow itself to spread out at all. It draws into a single line and holds. This is why, in all the careful searching anyone has ever done, No one has ever found one of these tiny pieces by itself, drifting solitary and free. Every attempt to isolate one ends the same way. The harder you pull, the more the force resists, until the energy of your pulling conjures new partners from the empty air, and the loneliness you were trying to create quietly undoes itself. The pieces exist only in company, only bound, only together, and the universe appears to permit no other way for them to be. We understand a great deal about this, and we can describe it with beautiful precision, and yet a complete proof of exactly why nature insists on it so absolutely remains one of the great unfinished problems in all of mathematics, still waiting, after all these years, for someone to solve it. So even here, in something so basic to what you are made of, there is a door not yet opened, a quiet question still resting in the dark. There is something to sit with in this, softly, as you lie here. We tend to think of solitude as the natural state of a thing, that anything can in principle be set apart, taken away on its own, held alone in the hand. But these tiny pieces at the heart of all matter cannot be alone ever, no matter how hard the universe is pressed to allow it. Togetherness is not their preference, it is their law. The loneliness of a single one of them is something the world will not bring into being, and so they remain forever paired, forever in company, woven into one another at the deepest level of everything that is. And so, in every atom of you, in your hands resting on the blanket and the slow rise of your breath, these smallest pieces are gathered in their little groups, holding to one another, bound by a grip that only tightens when tested. Content in a closeness that can never be broken and never needs to be. Two beads joined by a band that will not let go, resting quietly together in the dark, exactly as they have always been, exactly as they always will be. A single atom of a fading element will one day fall quietly to pieces, and nothing anywhere knows when. There are certain kinds of atoms in the world that are not entirely settled, atoms that carry a faint restlessness within them, and will at some unknowable moment transform, casting off a small part of themselves and becoming something new. We have watched this happen countless times. We can measure it with great care. And from all that watching, we have learned something that sounds at first like a contradiction, and then slowly opens into one of the gentlest mysteries of the small world. For a great crowd of these atoms, the future is wonderfully predictable. Gather a vast number of them together, more than you could ever count, and you can say with real confidence how the crowd will behave. After a certain stretch of time, half of them will have transformed and half will remain. Wait the same stretch again, and half of what is left will go, and so on. The crowd thinning in a smooth and faithful rhythm that we can predict to remarkable accuracy. This steady halving is so reliable that we use it as a clock, reading the ages of ancient bones and old stone and the long-cooled rocks of the earth by it. But now narrow your gaze from the whole crowd down to a single atom, just one, resting there alone. Ask it the simple question, when will you change? And here the confidence vanishes completely. There is no answer. Not a hidden answer we are too clumsy to read, but no answer at all. The atom carries no countdown, no ticking clock, no quiet schedule winding toward a chosen hour. It might transform in the very next instant. It might wait 1,000 years. It might wait longer than the universe has so far existed. And nothing about the atom itself leans one way or the other. Stranger still, the atom does not age. A fresh one, newly made, and an ancient one, that has waited patiently since before the earth was formed, are in exactly the same condition, with exactly the same chance of changing in the next moment. The old atom is not closer to its transformation for all its long waiting. It carries no memory of the time that has passed, nowhere, no sense of being overdue. Each instant for every one of these atoms is a fresh beginning, the slate wiped perfectly clean, the past pressing on it not at all. Think how unlike us this is. Everything we know grows older. A candle burns lower as the evening passes, and you can read the hours and how much of it remains. A face gathers its lines, a tree lays down its rings, a stone wears slowly smooth in the bed of a stream. To last a long time in our world is to be changed by the lasting, to carry the marks of all that time upon you, so that age and history are written into the very substance of a thing. But the restless atom carries nothing of the kind. It is like a coin that has been tossed 1,000 times and lands on each new throw with exactly the same even chance as the very first, wholly unmarked by all the throws that came before. However long it has already waited, the next moment finds it new, its odds unchanged, its history weighing nothing at all. It does not grow tired. It does not wind down. It is as fresh after an age beyond counting as it was in the first instant of its making. Now, whether this unpredictability runs all the way to the bottom of things, whether it is truly woven into the fabric of reality, or whether some hidden machinery we have never glimpsed is quietly deciding the outcome, is a question thoughtful people have turned over for a long time. Most who study it have come to believe the uncertainty is real and final, not a gap in our knowledge, but a feature of the world itself. Careful experiments have made the simplest hidden explanations very hard to hold on to. But it remains, in honesty, a question still open at its deepest edge and worth naming gently as such, rather than pretending it is fully settled. There is a strange and quiet peace in a thing that lives this way. The atom is not haunted by its past because it keeps none. It is not anxious about its future because nothing is bearing down on it. It simply rests in pure possibility, ageless and unhurried, neither waiting nor putting off, and when at last it changes, no clock struck the hour, no deadline arrived. The moment was not chosen by anything. It simply, softly came. So picture, somewhere in the deep dark, a single one of these atoms, glimmering faintly, perfectly still. It has waited, perhaps, for an age beyond imagining, and it is no older for the waiting, no nearer its change, no more tired than the day it was born. It carries no burden of time at all. It rests complete in this moment and the next, asking nothing, expecting nothing, simply being quietly for as long as it remains. The empty space in this room is not empty, and it never has been. We speak of empty space as a kind of perfect nothing, a clean and silent void where there is simply no thing at all. The gap between your hand and the wall, the dark air above your bed, the vast reaches between the stars, all of it seems to be pure absence. A stage on which things happen but which is itself blank and bare. And yet, when we look very closely at this nothing, with our finest understanding, we find that it is not empty in the least. It quietly seethes. It hums with a faint and ceaseless activity that never stops, not for an instant, not anywhere. The picture physicists most often reach for is this. Throughout all of space, even in the emptiest gap you can imagine, tiny pairs of particles are forever flickering into being and vanishing again, a appearing for the briefest sliver of a moment and then folding back into nothing before they can ever truly be caught. They rise and they wink out, rise and wink out, everywhere at once, far too quick and too small to ever be seen directly. Imagine the surface of water just beginning to simmer, faint bubbles forming and bursting in countless numbers, only far smaller and far faster. A soft and constant fizzing woven into the very fabric of emptiness. The void, looked at closely enough, is not a still and silent room. It is a quiet, restless sea. For a long time you might wonder whether this is only a story, a way of speaking, with nothing real behind it. But the seething of empty space turns out to leave fingerprints we can actually measure. Take two smooth, flat plates and hold them very close together facing each other, with only the thinnest gap between, and without any pull or push that the older physics could explain, the plates drift gently toward one another, drawn together by the restless sea around them. The reason, as best we understand it, is that the froth of the void presses on the plates from every side, and in the narrow space between them there is simply less room for that froth to gather. And so the constant pressing from outside, unbalanced, eases the plates softly together. The emptiness itself is pushing on them. This has been measured carefully in real rooms by real hands. The nothing is doing something. Sailors long ago knew a strange cousin of this effect. Two ships becalmed and floating close together on a gently swelling sea would sometimes drift mysteriously toward each other, eased together by the waves around them, the water between them too cramped to raise the same swell as the open sea beyond. The void behaves a little like that endless water, and the smallest things within it are nudged by its quiet motion, just as the ships were nudged by the sea. To see why the void can never be still, it helps to know that what truly fills all of space is not an emptiness waiting to be filled, but a set of unseen fields, present everywhere, stretched through every last corner of the cosmos. The particles we have been speaking of, the small bits of matter and the rays of light, are themselves only ripples and stirrings in these fields, like waves rising upon water. And just as the surface of a sea can never be made perfectly, mathematically flat, but always keeps the faintest tremor no matter how the wind dies, so these fields can never be brought entirely to rest. Even in their calmest possible state, the state we call empty space, they hold a low and ceaseless shimmer that cannot be smoothed away. This is what we mean when we say the void is full. It is not crowded with things. It is simply never truly quiet, because the very fabric of which space is woven can never be made perfectly still. And how much energy this faint and universal shimmer truly holds, and how it fits with the great unseen pull that shapes the cosmos as a whole, is itself one of the deepest unsolved puzzles we have. A quiet riddle still sitting unanswered beneath the calm, dark surface of everything. There is something to rest in here, in the dark as the room holds you. We imagine emptiness as the most peaceful thing there is, a pure and final stillness, and we sometimes long for it. But the universe seems to hold no such perfect emptiness anywhere. Even the deepest void is alive with a faint and tireless stir, a soft activity that can never be switched off, woven into the deepest level of what space itself is. There is, it seems, no true nothing to be found. Wherever you look, however empty it appears, the world is quietly, gently busy, humming to itself in the dark. So let the room around you be, for a moment, what it truly is. Not a blank and silent void with you alone inside it, but a calm and endless sea fizzing softly with countless tiny sparks too brief to see, never still, never empty, holding you within its quiet motion the way water holds a drifting boat. The dark is not absence. The dark is full and faintly, endlessly alive. Everything you are made of has a perfect twin, identical in every way but exactly opposite. For each kind of particle in the world, the universe knows how to make a mirror version of it, a partner that matches it in mass and in nearly every quality, yet carries the opposite charge, as though it were a reflection stepped out of a mirror. We call this mirror matter antimatter, and though the name sounds like something from a far-fetched story, it is entirely real. It is made in laboratories. It drifts down through the sky inside cosmic rays from deep space. It is even given off, faintly, by ordinary things, so that a single ripe banana with its trace of a certain restless element gives a quiet sputter of antimatter into the air every so often, harmless and unnoticed in the bowl on your kitchen counter. The most wonderful part of the story is how it was found. Long before anyone had ever seen a scrap of antimatter, a physicist working through the mathematics of the electron noticed that his equations seemed to describe not one kind of particle but two, the familiar electron and a strange opposite of it that no one had ever observed. He might have dismissed it as a flaw in the math. Instead, he trusted the equations and suggested, quietly, that this mirror particle might truly exist out in the world, waiting to be found. And a few years later, it was found, exactly as the mathematics had foretold. The universe had been carrying this hidden twin all along, and a pattern of symbols on a page had pointed straight to it. When a particle and its mirror twin meet, something happens that happens almost nowhere else in nature. They do not collide or bounce or break. They vanish, both of them together, the whole of their substance turning instantly into a burst of pure energy, a flash of light, leaving not the smallest fleck of matter behind. Two things become no things, and a little radiance is all that remains. It is the most complete disappearance the universe allows, matter and its opposite, erasing one another perfectly, paying out everything they were as energy in a single bright moment. We have even put this to gentle use. In certain hospital scans, a person is given a substance that gives off these mirror particles, faintly, from within. Each one, almost the instant it is born inside the body, meets an ordinary particle, and the two annihilate in a tiny flash of light, and machines arranged around the body catch those flashes and trace them back, building a picture of the soft inner workings from these countless little disappearances. A glimpse inside a living person, drawn entirely from matter and antimatter, quietly erasing one another, deep in the tissues, again and again. And here is the deep and honest mystery at the heart of it, the question no one can yet answer. When the universe was very young and very hot, in its first moments, it should, by everything we understand, have made matter and antimatter in perfectly equal amounts. But if it had, every particle would have met its mirror twin and vanished, and the cosmos would have ended as nothing but a sea of fading light, with no stars, no worlds, no us. That this did not happen means that somehow, for reasons we do not understand, the early universe tilted, ever so slightly, toward matter. For every great multitude of mirror pairs that met and vanished, a single extra speck of ordinary matter was left over with no twin to erase it. And everything that exists, every star and stone and living thing, every atom of you, is built from that faint leftover, that tiny imperfection in the balance. Why the scales tipped at all is among the great unsolved questions, still genuinely open, still waiting. There is something to hold quietly in that as you rest. You exist because of an imbalance so slight it is almost nothing. A whisper of asymmetry in a universe that seems to have wanted very nearly to be perfectly even, to cancel itself out and leave only light. You are the part that did not cancel. You are what remained when almost everything met its opposite and disappeared. So picture a still mirror in a darkened room, and your own faint reflection within it, the two of you almost perfectly matched, almost perfectly opposite. And imagine that the whole world began as a kind of balance like that, something and its reflection, nearly equal, nearly canceling, tilted at the last instant by the smallest breath toward being. The mirror holds, the reflection waits, and you remain, here in the quiet, the part that was left behind to exist. The tiniest pieces of you would weigh nothing at all if not for an invisible ocean that fills the whole of space. It seems the most obvious thing in the world that matter should have weight, that the small pieces things are built from should be heavy in their own right. But when we look closely at the most fundamental specks, the truly elementary bits at the bottom of everything, we find something surprising. On their own, left to themselves, several of them would have no weight whatsoever. They would not be heavy. They would simply rush about at the speed of light, weightless and free, never slowing, never settling, unable to gather into anything at all. The weight they do have, the heaviness that lets them slow down and clump together into atoms and stars and bodies, is not really theirs. It is something the universe lends them. It is lent to them by a field, an invisible something that fills all of space, every corner of it, evenly and everywhere, including the space in this room and the space inside you. We cannot see it or feel it directly. It has no color and no sound, and offers no resistance to your hand as you move it through the air. And yet the smallest particles, as they travel through this field, feel a kind of drag from it, a gentle clinging, and that clinging is what we experience as their weight. The more strongly a particle clings to the field as it passes, the heavier it is. The more lightly it slips through, the lighter. And a few particles, the light itself among them, ignore the field entirely, feeling no drag at all, and so they have no weight and race along forever at the fastest speed there is. There is an old and homely way to picture this. Imagine a great room full of people, milling about, chatting in clusters. Now imagine someone very ordinary walking across the room. No one turns to look, no one gathers near, and the person crosses easily, quickly, hardly slowed at all. That is a light particle, slipping through the field. But now imagine someone beloved and famous walking into the same room. At once people cluster around them, crowding close, and the famous person can barely move, inching across the floor, weighed down by the gathering crowd. That gathering, that clinging of the crowd, is what gives the particle its heaviness. The field clusters around it as it tries to pass, and the clustering is its weight. And spare a thought for the ones that feel nothing at all. Light itself slips through this great field without the slightest drag, ignored entirely, gathering no crowd around it as it goes, and so it has no weight and can never slow, racing across the universe at the only speed it knows. Without the field, everything would be like that. Every last particle weightless and unstoppable, flying apart forever at that same impossible speed, never pausing, never settling, unable to gather into so much as a single atom. There would be no clumping, no cooling, no coming together at all. No stars could form, no worlds could gather out of the drifting dust, and there would be no you to lie here in the dark and wonder at any of it. It is the gentle drag of the unseen ocean, slowing some things while letting others fly free, that lets the universe ever settle down enough to build a single lasting thing. For a long time, this was only an idea, a beautiful guess about how the smallest things come to be heavy. But an idea like this makes a promise. If such a field truly fills all of space, then it should be possible, with enough effort, to make it ripple, to strike the invisible ocean enough to raise a single wave from it, a fleeting disturbance that would reveal the field was really there. And so, after a hunt that lasted half a century, in one of the largest machines humankind has ever built, physicists struck the field hard enough again and again until at last a ripple appeared, a brief and telling tremor in the invisible ocean, exactly the kind the idea had foretold. The field was real. The ocean was truly there and had been all along, filling everything, lending weight to the world. This explains how the fundamental specs come to be heavy, though it leaves a deeper riddle quietly untouched. The question of why each kind of particle clings to the field exactly as much as it does. Why the weights come out in just the amounts they do, and not others. That piece of the mystery remains unanswered. One more thread of the larger and still unfinished story of what mass truly is. There is something to rest in here, in the stillness. The heaviness of things, the very property that lets matter gather and settle, that lets a body have weight and sink softly into a bed, is not locked inside the particles like a hidden stone. It is something the universe gives moment by moment, as those particles move through an unseen ocean that is everywhere at once. Your weight is, in a sense, a gift of the empty seeming space around you and within you, an ocean you cannot perceive but cannot leave, lending you your place in the world. So let yourself feel held by that, as you lie here. All around you and all through you, this invisible ocean lies still and clear and endless, asking nothing, lending its quiet weight to every small thing it touches, steady and silent and everywhere, the unseen water in which the whole world gently floats. Every atom in the universe is very nearly the same size, the ones cradled in your hand and the ones burning inside the farthest star. This is a quietly astonishing thing, once you sit with it. You might expect atoms to come in wildly different sizes, the heavy ones vast and the light ones tiny, the way a boulder dwarfs a pebble. But they do not. From the lightest atom to the heaviest, across the whole long family of them, the difference in size is gentle and small. They are all, more or less, the same width. A width so tiny that millions could rest across the breadth of a single thread, and yet a width that holds remarkably steady from one kind of atom to the next. A heavier atom, with far more crowded into its core, does not swell up larger. Its stronger core simply pulls its surroundings in more tightly, and so it stays close to the same size as its lighter cousins. The atom has a preferred size, and it holds to it, and that size is not an accident. It is set precisely by a handful of deep numbers woven into the fabric of reality, the fundamental constants of nature, how strongly charges pull on one another, how much the smallest things resist being pinned into a tiny space, the basic graininess of the world itself. These few quiet numbers, fixed and unchanging, combine to dictate exactly how large an atom must be. The size of the atom is written into the constants of the universe, the same constants here in your room as in a galaxy at the very edge of what we can see. And so an atom there is the same size as an atom here, built to the same measure, because the same deep numbers hold sway everywhere. Now here the ground grows softer, and we must step carefully, for we move from what we can measure into what we can only wonder about. Those few numbers that set the size of the atom, and so much else besides, appear to be balanced with a strange and striking delicacy. Were they even modestly different, the consequences would be severe. Atoms might not hold together. The patterns that let atoms join into the rich variety of substances might never form. Stars might not be able to shine in the steady way that warms a world long enough for anything to grow. The very possibility of chemistry, of stars, of life, of you, seems to rest on these numbers falling within narrow bounds, and they do fall within those bounds, and no one knows why. This is a real puzzle, and an honest one, but it is important to be clear about what kind of puzzle it is. We do not know whether these numbers could have been different, or whether some deeper law we have not yet found requires them to be exactly what they are. We do not know whether ours is the only universe, with its single set of numbers, or whether there might be countless others with different settings, most of them barren, so that it is no wonder we find ourselves in one of the rare ones where things hold together. We do not know whether the fitness of the numbers points to something meaningful or is simply how things happen to fall. These are open questions, genuinely unsettled, debated thoughtfully by careful people who reach different conclusions, and none of the proposed answers has been shown to be true. It is one of the places where our understanding quietly runs out, and we are left, for now, simply gazing at it. There is something to hold gently in that, as you rest in the dark. The size of the smallest things, and through it the possibility of everything large enough to matter to us, hangs on a few numbers we can measure with exquisite care and cannot yet explain. It is a mystery we have not solved and may not solve for a very long time. And there is no shame in that, only a kind of wonder, the clean and open wonder of standing before something we do not understand and being honest that we do not. So picture this: an atom resting in the palm of your hand, and an atom glowing in the heart of a star so distant its light left long before you were born. Both of them exactly the same size, both built to the same unexplained measure, matched across all that emptiness as though by some quiet agreement written into the world itself. The same tiny pattern, repeated everywhere, here and there and out to the farthest dark, all of one size, glimmering softly across the whole of the universe. Every electron in the universe is exactly, perfectly the same, and one strange idea once held that this is because there is only one of them. Begin with the plain fact, which is wonder enough on its own. The electron is one of the basic pieces from which the world is built, present in unthinkable numbers in every speck of matter, in your hand, in your breath, and the light of the lamp. And every single one of them is identical to every other. Identical in the most complete and absolute sense the universe permits. Not merely similar, not nearly the same, but exactly the same, with no difference whatsoever, no mark, no scratch, no flaw, no private history that could ever tell one from another. If you could take any two electrons in all of existence and quietly swap their places, the universe would carry on without the faintest flicker of change, because there is, in truth, no fact about which one is which. They are interchangeable in a way that nothing in our familiar world ever is. For even 2 grains of sand or 2 drops of rain carry their own small differences. The electron has none. Each is a perfect copy of all the rest. This perfect sameness is so strange that, long ago, 2 physicists found themselves turning it over late one night, and one of them offered the other a wild and beautiful thought. What if all the electrons are identical? He wondered, simply because they are all the same electron. What if there is only one electron in the entire universe, a single solitary particle, weaving back and forth through time, threading through every moment again and again, so that everywhere we look and find an electron, we are really seeing that one lonely traveler, glimpsed at a different point along its endless journey. On this strange picture, the countless electrons in you and in everything would not be countless at all. They would be one, met over and over, the way you might see a single thread appear and reappear across a woven cloth. Imagine a needle stitching slowly through dark fabric, passing through to the underside, then back up to the surface, then down again, on and on. If you could see only the top of the cloth, you would find a great scattering of bright stitches, and you might think them many separate threads. But they are one thread, one needle, the same single line passing through again and again. The strange old idea pictured the universe a little like that cloth, and every electron in it as one more place where the single thread breaks the surface, the same traveler, seen at a different stitch. It is a lovely thought, and I should be clear and honest with you. Almost no one believes it is actually true. It was never meant as a settled claim, only as a flash of inspiration shared between friends, and it runs into a plain difficulty. For if the one electron were truly weaving back and forth through time, it would have to spend as much of its journey going backward as forward, and a particle going backward would appear to us as the electron's mirror opposite, its antimatter twin. The idea therefore predicts that the universe should hold just as much of that mirror matter as ordinary matter, and it does not. So the one electron picture stands today not as a fact about the world, but as a discarded and beautiful fancy, the kind of idea that, even in being wrong, helped point the way toward truths that were right. And the perfect sameness, unlike the fancy it inspired, is no mere notion, but a thing with real and measurable weight in the world. Because the pieces are so utterly indistinguishable, they do not behave the way a heap of separate, tellable apart things would. The way they settle into an atom, stacking neatly into their ordered places, the way vast numbers of them flow and arrange themselves through a metal or a crystal, even the way certain substances chilled to the very edge of cold can slip together into a single shared state and move as though they were one thing rather than many. All of it follows from this deep interchangeability. The universe does not treat them as a crowd of individuals, each with its own identity, but as expressions of one identical kind, and the visible world is shaped in countless quiet ways by that fact. Their sameness is not a curiosity tucked away at the edge of things. It is woven into the very way matter behaves, and yet the fact it sprang from remains and is nearly as strange as the fancy itself. The electrons in you really are all perfectly identical, every last one, indistinguishable down to the deepest level the world allows. Whether that is because they are secretly one, or simply because the universe makes them from a single perfect pattern. The sameness is real and profound and quietly humbling. So let this rest softly with you, my friend, here in the dark. Whether they are many or in some impossible way. 1. The smallest pieces of you are perfect copies of the smallest pieces of everything. The same in the stars, the same in the sea, the same in the hand of someone you love. Picture, if you like, that single needle drawing its one bright thread slowly in and out of the dark cloth of all of time, never hurrying, never tiring. Each gleaming stitch the same lonely traveler passing through once more, weaving the whole of the world from a single quiet line. Somewhere in the sky tonight, there is a star so dense that a single spoonful of it would weigh as much as a mountain. To understand what such a thing is, begin with the emptiness of ordinary matter. An atom, as it rests in your hand or your bed, is mostly empty space. A tiny dense core surrounded by a vast hollow region where its lightest pieces drift. The core itself unimaginably small against all that surrounding room. This emptiness is everywhere in ordinary things, and it is, in a quiet way, a kind of grace. It is the reason matter can be soft, the reason your body can be light and supple and yours, the reason there is room inside everything for warmth and motion and life. The roominess of the atom is woven through all of it. But the universe knows how to take that emptiness away. When a very large star reaches the end of its long life and can no longer hold itself up, its core begins to fall inward under its own crushing weight. Gravity pressing harder and harder, squeezing the matter together with a force beyond anything in our experience. At first, the tiny pieces of the atoms resist, refusing to be crowded, holding the emptiness open as they always have. But the weight is too great. The pressure mounts until the resistance finally gives way and something extraordinary happens. The lightest pieces, the ones that drifted in that vast outer space, are driven inward and pressed into the core itself, merging with the particles there, until the empty room of every atom is simply gone, crushed out of existence. What remains is no longer a crowd of separate atoms with space between them. It is one single, continuous mass, packed as tightly as matter can be packed, as though the whole star had become one colossal core, one enormous heart of an atom, miles across. This is a neutron star, and its density is almost impossible to hold in the mind. Imagine taking a small spoonful of its substance, no more than would fit on the tip of a teaspoon. That tiny scoop would weigh as much as a mountain, perhaps as much as all the people on Earth together. A whole star's worth of matter, more than fits in our own sun, crushed down into a sphere no larger than a city, small enough to rest within the bounds of a town, yet so heavy that its surface gravity beggars imagination. A pebble dropped from a small height onto such a star would strike with a violence past all reckoning. And many of these stars spin, some of them turning hundreds of times every second, a city-sized ball heavier than the sun, whirling in the dark faster than the blades of a fan, steady and silent and unthinkably dense. What holds it up, what stops gravity from crushing it down to nothing at all, is the same kind of stubborn refusal we meet in the smallest things, the insistence of those crowded pieces that they will not be packed any tighter, a resistance pushed almost to its very limit, holding the line against a weight that would otherwise win. It is matter pressed nearly as far as matter can go, balanced at the edge of what is possible, a stillness made of unimaginable strain. Many of these crushed stars send a sign of themselves out across the dark. As they spin, some of them cast two narrow beams of energy from their poles, sweeping them round and round like the turning lamp of a lighthouse, so that to a distant watcher, the beam flashes past again and again with astonishing regularity, a faint and faultless pulse arriving out of the deep. When such pulses were first noticed, ticking so steadily from somewhere far out in space, they seemed almost too regular to be natural. And for a little while, no one was quite sure what could possibly be sending them, so perfect was their rhythm. It turned out to be these tiny titanic stars, the crushed remnants of dead giants, turning silently in the dark and brushing the cosmos with their beams. Some of them keep a time so exact that they rival the very finest clocks we have ever built, a dead star spinning faithfully out in the void, marking the seconds more truly than any watch on Earth. There is something to rest in here as you lie in your soft and roomy body in the dark. The emptiness inside your atoms, the vast gentle space that lets you be light and warm and alive, is something the universe can take away. And out among the stars, sometimes it does. What is left when the emptiness is gone is a glimpse of the other thing your matter could be, pressed to its absolute limit, dense beyond imagining, a hint of the hidden extremity sleeping inside even the softest things. You carry that possibility within you, and yet here you are, roomy and unhurried, your atoms holding their emptiness open, your body soft against the sheets. So picture it, far out in the quiet dark, a single small sphere no larger than a city, holding the weight of a sun, spinning silently against the stars, the most crowded stillness in all the universe. And then feel, by contrast, your own gentle weight upon the bed, your atoms keeping their vast inner rooms wide and open, your body light and warm and spacious, resting easy in the dark. We have built a theory so accurate that it is like measuring the distance across a whole continent and being right to within the width of a single hair. This is not an exaggeration, and it deserves to be felt slowly because it may be the most precise thing the human mind has ever achieved. There is a particular feature of the electron, a small magnetic quality it carries, that our best theory of how light and matter touch allows us to calculate. And when we calculate it, and then go and measure the real electron with our finest instruments, the prediction and the measurement agree, not roughly, not closely, but to something like 12 places past the decimal point. 12. Imagine being asked to guess a number and getting it right, digit after digit after digit, until you had matched a dozen of them in a row. That is how nearly this theory and the world fall into step. Of all the predictions humankind has ever made about anything, this is the most exact agreement between thought and reality we have ever found. And yet the strange thing, the thing that makes this more than a story of triumph, is how the theory gets there. When physicists first set out to make these calculations, the equations did not hand them a tidy answer. They handed back nonsense. Endless quantities, infinities, sums that ran off to forever and refused to settle into any sensible number. By all appearances, the theory was broken, choked on its own arithmetic, unable to yield a single usable result. For a while it seemed the whole beautiful structure might be hopeless. What rescued it was a careful and initially uncomfortable maneuver, a way of handling those infinities, of subtracting them against one another setting the runaway pieces aside in a disciplined fashion, until what remained almost miraculously was a finite number, sharp and clean and exactly right. The procedure worked. It worked better than anything had ever worked, but its very inventors were uneasy with it. Some of the greatest minds who built the theory confessed to a deep discomfort, a sense that they were performing a kind of sleight of hand, pulling a perfect answer out of a process that, looked at plainly, seemed to involve sweeping impossibilities under the rug. They could not deny that it gave the right answer, again and again, with breathtaking precision. They simply could not fully shake the feeling that they did not entirely understand why they were allowed to do it. In the years since, we have come to understand that maneuver far better, and it no longer seems quite so much like a trick. Deeper insight has shown it to be a reasonable and even natural way to handle a theory that describes the world at one scale while remaining honest about what it cannot yet see at smaller ones. The unease of the founders has softened into understanding, and still, beneath it all, a quiet wonder remains. The wonder that the world should yield to our equations so astonishingly well that reality should be willing to be predicted to 12 decimal places, and yet hold back just a little some final sense of why it works at all. And this same theory, for all its strangeness at the root, is not some remote thing locked away from ordinary life. It is the deep account of how light and matter touch one another, and so it quietly governs nearly everything you see. The warm glow of a lamp, the particular color of a flame, the way light bends and glances across the surface of water, the spark of electricity running silently through the walls around you, the very light entering your eyes at this moment and letting you take in the world. All of it lives within the reach of this single description, the most precisely tested humankind has ever written down. Every glow and every hue, every flicker of current, every image carried to you on a beam of light follows its quiet rules. The theory that needed such care to tame, that matches the world to a dozen decimal places, is also simply the story of how seeing happens, how warmth and color and brightness come to be at all. It is threaded through the most ordinary moments of your day, hidden in plain light. There is something to sit with in that, gently, as you rest. Our truest, sharpest description of how light and matter meet is at once almost perfect and quietly humble, a thing that matches the world with stunning exactness, while still carrying at its root a touch of the unexplained. We can predict the universe with a precision that borders on the miraculous, and we cannot fully say why we are able to. Both of those things are true at once, and there is a kind of beauty in holding them together, the triumph and the mystery side by side. So picture a single number, written out by hand on a page in a quiet room, its long tail of digits running across the paper, every one of them matching the world exactly, place after place after place. A tiny, perfect agreement between a human mind and the deep workings of reality, resting there on the page in the lamplight, almost flawless, and still, somehow, holding one last quiet secret of its own. Before you look at it, the smallest piece of matter is a haze of every possibility at once, and the moment you look, it becomes a single fact, and no one can say why. This is the deepest unsolved mystery in all of our understanding of the small world, and after 100 years of the finest minds turning it over, it remains genuinely, honestly open. It begins with something we can describe beautifully. When left alone, a tiny particle does not sit in one definite state. It hovers in a blur of many possibilities at once, here and there and everywhere it might be, all of them somehow held together, overlapping. None of them yet real in the way we mean when we say a thing simply is. We can write down, with perfect precision, how that blur of possibilities flows and shifts and spreads over time. Our equations track it flawlessly. They never miss. But then we look. We bring an instrument to bear, or simply catch the particle in some interaction, and in that instant the blur is gone. The particle is suddenly, definitely somewhere, here and not there, one outcome and not the others, a single plain fact, where a moment before there had been only a haze of maybes. The many possibilities collapse into one, and our flawless equations, which describe the blur so perfectly, fall silent on this. They do not tell us why this outcome and not another. They do not tell us what counts as a look, what exactly it is that turns possibility into fact. Is it the instrument, a single speck of dust brushing the particle, a living eye? Where in all of that is the line that separates the world of hovering maybes from the world of settled things? No one can point to it. This is the puzzle, and it has no agreed solution. What we have instead are stories, several of them, each a different way of imagining what might really be happening beneath the equations, and it matters to say plainly that not one of them has been shown to be true. They all fit what we see equally well. Careful people who have spent their lives on this disagree, deeply and in good faith, about which, if any, is right. One story says that the act of looking truly does collapse the haze into a fact, and that we should not ask what the particle was doing in between, that the blur is simply our best tool for predicting outcomes, and the question of what is real beneath it may not be a question we can answer. Another story is bolder and stranger. It says that nothing collapses at all, that every possibility genuinely happens, and that the world itself quietly splits at each such moment into separate branches, so that in one branch the particle is here and a version of you sees it here, and in another branch it is there and another version of you sees it there, and both are equally real. The universe forever dividing into countless parallel paths in which everything that can happen does. And a third story says the particle had a definite place all along, carried quietly by a real and hidden wave that guides it, so that the outcome was settled from the start, and only our ignorance of the hidden wave made it seem uncertain. The randomness merely a veil over an underlying order. These are not the only stories, but they are enough to show the shape of the mystery. Each is a complete and consistent way of seeing the world. Each saves all the appearances, and we have no way, at present, to look between them and learn which is true, or whether the truth is something no one has yet imagined. The equations give us flawless answers about what we will see and stay perfectly silent about what is. After all this time, the deepest question we can ask about the smallest thing remains unanswered, resting quietly where it has always rested. Waiting, there is in the end a strange peace in that, and you may let yourself feel it as you drift. We do not have to solve it tonight. The wisest among us have not solved it in a century, and the world has gone on turning all the same, the stars wheeling, the atoms holding, your breath rising and falling in the dark. Some questions can simply be set down gently and left to rest, their mystery intact, their beauty undiminished by our not knowing. So picture the question laid softly down, the way you might set a smooth stone at the edge of still water and step back, The haze of maybes hovers quietly, undecided to become anything at all. And you here, in the dark, no longer needing to know, let it be, and let yourself begin to drift. And so we come to the end of our slow wandering through the atom. If you have drifted off somewhere along the way, then these last few words are not really meant for you, and that is exactly as it should be. Rest easy. You carried nothing with you, and nothing was ever needed. The journey was only ever an excuse to let go. But if you are somehow still awake, still here in the quiet, with your eyes grown heavy, then know that there is no hurry to leave this gentle dark. There are other long, slow journeys waiting whenever you should wish for them. Other unhurried paths through the deep and the distant and the very small, each one made to be drifted through just like this one, with nothing to remember and nowhere to be. If you would like to keep floating a while longer, another is only a breath away, ready to carry you softly onward. And if you would rather simply sink now into sleep, that is just as good and perhaps better. Before you go, let me leave you with one quiet thought to carry down into rest. You are made of the very things we have wandered among tonight, the tiny cores and the soft clouds, the held forces and the trapped and humming light. Every atom in you was forged long ago in the fierce hearts of stars, scattered across the dark when those stars died, and gathered up again over unimaginable time into the warm and breathing shape of you. You are, quite truly, made of star stuff, resting here for a little while in the dark, and one distant day far beyond all our reckoning, these same atoms will loosen and drift on to become something else, somewhere else, beneath some other sky. For tonight, they are gathered here as you at peace. So let your breath slow, let the last of the day loosen its hold and fall away. Let the bed take all your weight, and let the quiet close softly around you. Sleep gently now, my friend, and sweet dreams among the stars.